The Basics of Wood by Jeremy Jocelyn. History of light wood framing construction. First developed in the first half of the 19th century, wood light frame construction was first an American-built system. Wood light frame construction was also able to eliminate heavy timbers and mortise and tenon framing. The balloon frame was the earliest wood frame construction without using large timbers, made of joists, studs, and rafters, held together by newly inexpensive machine-made nails. The problems with balloon frame buildings was that the studs went all the way up to the roof, where it was difficult to install and also created little chimneys during fires and spread fire quickly. That brought on the development of the platform frame. The platform frame. The platform concept is that a floor is built, then walls are built on top of the floor. The next story is built on top of those walls, and on those walls the attic and roof are built upon. Advantages of the platform frame against balloon framing are shorter, easier to handle wall pieces, fire blocking provided at each floor, and platforms are convenient work areas. One disadvantage of platform framing is that there can be a relatively large amount of vertical shrinkage. Conventionally made of nominal 2-inch members, studs can be cut to exact length, delivered, and ready to install with nails. Each stud is installed parallel to each other at specific intervals. Cross pieces are installed to maintain the intervals, and sheathing is applied to the face to stabilize the structure and prepare it for finishes. The floor structure is made of floor joists, rim boards, and a subfloor. In a wall structure, there are studs, sole plate, and a top plate. For roofs, there is a lower cross piece and a ridge board and rafters. Openings in the floor and roof are framed with headers and trimmers. Openings in walls have sills, trimmer studs, and headers. In platform framing, sizes of members fall on a 4-foot module to ensure the use of 4x8 sheeting. Foundations for light frame structures. Once made of stone or brick, now reinforced concrete and concrete masonry are used in foundations. They consist of spread footings, basement or crawl space walls, and slab on grade. For simple basements, water protection usually consists of bituminous or cement plaster damp proofing, with a combination of drain tile to draw water away from the walls. Slabs on grade are also protected from water with heavy plastic vapor barrier sheets. There may be a need for protection from radon gases too, depending on the soil conditions. Foundations or basements must also be insulated for energy conservation codes. Insulation is used on walls and floors to reduce heat exchange between the building and soil. There are also other materials used to build foundations. In regions too cold for masonry or concrete, the foundation can be built with preservative-treated wood, similar to a regular wall. There are also ICF, insulated concrete formwork, which comes insulated, and no need for removal formwork. There is also precast, but joints between pieces need to have special attention for water penetration. Building the frame. The first step to building the frame is planning the frame. Experienced carpenters can frame a simple building from the most simple of drawings. But in some more complex buildings, drawings may have to go into detail, as much as concrete or steel structures. Size and spacing for joists and rafters is found on framing plans. Section details show a cut through the building to show major connections in the building. Floor plans are drawn from a sky view that show where to place walls and roof slopes. Elevations can either be interior or exterior and show kitchen layouts or other elaborate features. Erecting and attaching to the foundation. Rough carpentry is the building of the platform frame structure. Each part of the building is built so there is a platform to provide a work area for building the next area. Attaching the frame to the foundation is done with a sill plate. A sill plate is used for the base of wood framing by attaching it to the top of the foundation. Most buildings use nominal 2-inch piece of lumber for this, but in a building that will face heavy wind and seismic loads, multiple pieces may be used. A sill seal is used between the sill and the foundation to stop drafts and moisture waking up from the foundation. Floor framing. Solid lumber floor joists range from 2x6 to 2x12 pieces with spacings of 16 to 24 inches on center, based off the use of 4x8 subflooring. Floor joists are made up of joists, which are used in a parallel array to support the floor deck, and a rim joist, which runs perpendicular to the joist to primarily close the outside face of the floor. Floor openings are supported by headers and trimmers. A header is used to support other perpendicular framing members above wall openings or joists supporting around floor openings. A trimmer is a joist that supports a header around the opening of the floor. Today, manufactured I-joists are common in floor framing to replace solid lumber. Manufactured I-joists are lighter and can span greater distances. They're also easier for running utilities. Subflooring is used on top of the floor joist. Subflooring is a load-bearing surface underneath the finished floor. Wall framing. Wall framing usually consists of 2x4 or 2x6 lumber. In a wall frame, there are 3 pieces: the stud, the sole plate, and the top plate. Studs are vertical pieces in the wall framing, placed in a parallel array. A sole plate is the bottom member in a wall section. The top plate is a horizontal piece at the top of the studs. In walls over 10 feet high, they must have some sort of blocking mid-span to increase strength and fire resistance. Wall sheathing is usually plywood or OSB, which stiffens the wall in areas where more strength is needed. Lead and diagonal bracing can also be used. To prevent overturning or the house or roof being lifted, hold downs are used. To prevent racking, wall sheathing is normally sufficient, but in some cases special built shear walls are used, and also lead and diagonal bracing. Lead and diagonal bracing are diagonal members used in the wall section to resist lateral forces in the building frame. A shear wall is a stiff wall that resists lateral forces in the building frame. Sheathing is a rough covering applied to the outside of the wall. Upper levels and roof framing. From the completion of the first floor, the following floors follow similar steps in construction. For roofs, there are many different types of roof shape. flat, shed, gable, hip, gambrel, and mansard are all examples. In a gable and hip roof, most commonly ceiling joists or triangle structures support the roof, but a ridge beam is also used. Wood rafters must also be tied down. The roof consists of three parts: the rake, the lookout, and the fly rafter. The rake is a sloping edge on the steep roof. The lookout is a short rafter running perpendicular to the other rafters, creating an overhang. The fly rafter is a rafter in a rake overhang. Rafters are the members that run up and down the slope of the roof. Ridge beams are structural beams supporting the upper ends of the rafters where the bottoms are not tied. Collar ties are a wood member nailed to two opposing rafters to resist wind uplift. In hurricane areas, roofs must be specially secured with sheet metal anchors, and other care is taken in the building of these roofs so that they are stronger. Variations on wood light frame construction. Thermal efficiency. Originally 2x4s have been used in all framing of houses, but now increased pressure on energy conservation is pushing for the use of 2x6 exterior walls to increase space for insulation. Optimal lumber usage. Advanced framing techniques are used to eliminate redundant wood members to minimize the use of lumber. Larger stud spacing in exterior walls reduce the use of lumber and also increase thermal resistance. Designed to a 24-inch module also reduce waste. Using single top plates by aligning joists with the wall studs is another way to reduce waste. These and other methods should always come with guidance from a structural engineer to ensure that the building is still safe. Prefabricated assemblies. Roof and floor trusses are commonly used prefabricated assemblies because of the increase in building speed. Most of these assemblies use a small crane, usually attached to a truck, to be placed in sections. Construction and building codes. In wood frame construction, building codes restrict building size based on fire resistance. An unprotected commercial office may only be built of 2 stories with 9,000 square feet per story, while a building with heavier timber construction can be built 5 stories with 36,000 square feet per story, and the size is increased with fire-resistant materials and sprinkler systems that are incorporated. Other building codes call for separation between townhomes by a firewall, which is made out of which used to be made out of brick and block, but now can be built with steel frame and gypsum board. The uniqueness of wood light frame construction. Wood light frame construction is so popular because of the possibilities of construction and because it is economical compared to other construction. It creates a competitive supplier and builder market. It can be used to build cookie cutter houses to brilliant Queen Anne and shingle style homes of the 19th century. Plastic lumber are lumber-like products made entirely or mostly of plastic resins, manufactured from one or more resins that can be mixed with rubber, wood waste, glass fiber, or other materials. Formed into solid or hollow shapes mimicking conventional lumber. Plastic lumber is also resistant to sun, water, and insects, creating for a maintenance-free product. Exterior decking, trim, fence, and site furniture claim the largest share of plastic lumber use. SGPL, or structural grade plastic lumber, is made from HDPE, or high density polyurethane. Reinforced with glass fibers, can be as strong as conventional wood, but is usually prone to long-term creep and is less stiff. Wood panel products. Useful in many building applications and usually come in 4x8 panels. Wood panel products are used because they are more efficient on resources and labors, using recovered or recycled wood waste and covering more surface area than standard wood sizes. Structural panel types. Structural wood panels include plywood, composite panels, and non-veneered panels. Plywood is made up of thin layers of wood veneer, glued together with interior crossbands running perpendicular to counter the effect of moisture-related movement. Composite panels have two parallel-faced veneers bonded to a core of reconstituted wood fibers. Non-veneer panels are made from a variety of reconstituted wood fiber materials. Orientated strand board, or OSB, uses long strands of wood compressed and glued at similar orientations as plywood. Made at 3 to 5 layers, OSB is the strongest and stiffest type of non-veneered panel and is generally more economical than plywood. Particle board is manufactured with smaller wood particles than OSB, with different density ranges. Mainly used as a base material for wood veneer and plastic laminates. Fiberboard is a very fine-grained board made from wood fibers, most commonly used in cabinets, furniture, moldings, paneling, and other manufactured products. Plywood production. Veneers for plywood are rotary slice. The strips are cut and dried to a moisture content of about 5%. After sheets are repaired and machine spreads glue over them, they are laid together and required in the required sequence and grain orientations. Veneers are turned into plywood after pressure and heat is added. Panels are graded and grade stamped. High-grade panels are sanded smooth, but sheathing and subfloors are only lightly sanded, or not sanded at all, to prevent slightly reducing their thickness. Where really smooth and durable panels is needed, one or both sides may be coated with a resin-treated overlay. Structural panels are used for things such as subfloors or sheathing. Panels may be specified either by thickness or by span rating. Span rating is determined by laboratory load testing and specifies the allowed spacing between rafters for roofs and joists for floors. When specifying panels by thickness, it is done very similar to dimensional lumber. Structural panels may only deviate from their performance category by 1/32 to 2/32 of an inch. Panels also have bond classifications. Exterior or exposure 1 are the two classifications for structural wood panels. Exterior is rated for applications permanently exposed to the weather. Exposure 1 is used for pieces that will be protected once the building is finished, but must endure long exposure to the elements during construction. Other wood panel products. Hardboard is a thin, dense, highly compressed panel. It comes in various thicknesses, surface finishes, and can also be durable against weather. Insulating fiber sheathing is a low density panel, usually 1/2 to 3/4 of an inch thick. It has some insulating value and is usually used as a non-structural wall sheathing, usually made from wood, vegetable, or recycled fibers. Hardwood plywood panels are made from birch, maple, popple, or alder, and are popular for cabinetry or other finished carpentry. Non-wood fiber panels are also used. Also known as agrifiber or biocomposite panels, they are made from agricultural waste. Structural strawboard panels are usually made from straw that is faced with a veneer on each side. These panels range from 2.5 to 8 inches thick and have significant structural capacity that can be used to replace conventional wood stud framing. Non-structural panels made from compressed agrifiber range from sizes 1/4 to 1 1/8 inch thick. These can be used to replace MDF particle board or interior plywood. Wood chemical treatments. There are two different types of chemical treatments in wood: fire retardant treatment and preservative treated wood. Fire retardant treatment is impregnating wood with certain chemical salts and is usually expensive. Preservative treated wood is used where decay or insect resistance is needed. Preservative treated wood. For preservative treated wood, there are many preservative chemicals: oily solutions, copper solutions, and termite repellent compounds. Oily preservative chemicals include creosote and pentachlorophyll. Oily preservatives have a tendency to be toxic and have an odor. Also, they are unpaintable. Some copper solutions are chromatic copper arsenate, which have been phased out because of the toxicity. Alkaline copper quat, copper boron azote, and micronized copper are also examples. All these solutions are still considered potentially hazardous and are also corrosive to many metals. Borate compounds are non-toxic to humans and are used to resist termites. These treated lumbers must be protected from lumber though. There are all still new ways being evolved to produce preservative materials. Non-metallic treatments and heat-treated processes are now being introduced. Then there are also naturally decay-resistant woods. Some woods are naturally resistant to decay, such as redwood, cedar, black lotus, and black walnut. Redwood and eastern red cedar, as specified, are termite-resistant species. There are also durable construction techniques that are used to prevent the decay of wood. Keeping clear of soil, ventilating attics and crawl spaces, good water shedding, avoiding condensation, and repairing roof and plumbing leaks immediately can all prevent wood decay. Wood fasteners. Structurally, fasteners are often the weaker link in wood construction. It is usually impossible to use enough fasteners to get the full strength of the members being joined. Adhesives and tooth-plated connections are capable of achieving full strength, but are limited to factory installation. Otherwise, nails are the favored means of fastening because they are inexpensive, quick, and easy. There are many types of nails. There are also machine-driven nails. Today, a lot of nailing is done with a powered nail gun instead of by hand. These are use either pneumatic or internal combustion to drive nails. Screws are another method. They are spiral threaded fasteners that are installed by turning, which draws them into the wood. Screws have better clamping power than nails and can be more precise, but cost more and take more time to install. Bolts are another method that are mainly used for heavier structural connections, installed through pre-drilled holes and then tightened down. Other wood fasteners are timber connections. Timber connections are specially designed connectors that can provide increased load carrying capacity over bolting, screwing, or nailing. Their split ring and timber rivets are example of timber connections. Tooth plates are similar to timber rivets, but are lighter and used in factory production. Plates are driven in the wood with hydraulic press and pneumatic presses or rollers. They are effective and economical connectors. Sheet metal and metal plate framing devices are also used. There are many different types of sheet and plate metal devices used to join together wood. Then there are wood adhesives. Structural wood adhesive can be as strong as a member being joined, and structural wood adhesives can be made either weather resistant or limited weather resistant. Prefabricated and manufactured wood components. All wood products and connection methods may be used in prefabricated components because of controlled factory conditions. They are structurally sound and precise, and they also minimize work and waste on the construction site. Prefabricated components consist of trusses, prefabricated panels, and factory-built housing. Both roof and floor trusses are manufactured in small plants all across the United States. They are generally more cost, waste, and time effective, but have limitations on building designs. Prefabricated panels are simple sections made from dimensional lumber and plywood that can be rapidly nailed together to complete a building frame. Some panels come pre-insulated, called SIPs, or structurally insulated panels. Factory-built houses are houses built completely in a factory, then brought to a prepared foundation and set on the foundation. They are usually built to comply with building codes and are sold at a fraction of the cost of conventionally constructed homes, but have shorter life expectancies.